Chapter
1,
Section 3.
So a big part of Section 3 is conversions, and an easy way to remember what to convert to what is an acronym, and that is King Henry died dash drinking chocolate milk.
This stands for kilo, which is 10 to the third, hecto, which is 10 squared, deca, which is 10 to the first. These are your SI units, which is meters, liters, and grams. 10 to the negative 1, which is deci, 10 to the negative 2, which is centi, and 10 to the negative 3, which is milli.
Lindsay, back to you.
The section in Chapter 1 that my group was assigned was Section 3, and a really big part of that section is dimensional analysis. And anybody who's studied physics will tell you that dimensional analysis is a huge part of understanding the subject. And for those of you that don't know, dimensional analysis analyzes the dimension of a subject, which are base or derived units.
Oh, didn't see you there. You want to learn about some base and derived units? Here we go. So this poster shows the base and derived units that we've learned this chapter for Chapter 1. So to start off with base units, these are used in simple conversions, which we all should know how to do by now. To start off, time is measured in seconds, mass is measured in kilograms, and distance is measured in meters. Now if we take a look at our derived units, we use derived units during dimensional analysis, and they are different from base units because in order to get a derived unit, you have to put two base units together. So the first one that we use this chapter is velocity, which is measured in meters per second, and then the second one we did was acceleration, which is measured in meters per second squared. Now let's look at some example problems.
So if we're given 500 millimeters, then you move it 3 decimal places to the left, so 1, 2, 3, and that's going to give you 0.5 meters. And the second way to do this is use cross multiplying. So you write what you were given, which is 500 millimeters over 1. And you just have to know that there are 1,000 millimeters in 1 meter. So your units can cancel out and you're left with meters, which gives you the same answer, which is 0.5 meters.
Some conversion problems may be a bit trickier in which you can't use King Henry died drinking chocolate milk. This is an example of it. Say if you have 54 meters per second and you're trying to get to kilometers per hour. First, you know that there's 1,000 meters in 1 kilometer, so those cancel out. And there are 3,600 seconds in 1 hour, so those cancel out. After your calculations, you will get a final answer of 194.4 kilometers per hour.
Dimensional analysis?
Yes, please. So this is an example of a dimensional analysis problem, and we are asked to solve for M2. We have our units over here. F is force, which is measured in newtons. M is mass, measured in kilograms. D is distance, measured in meters. And the problem gives us G, which is measured in nm squared over kg squared.
So the first thing that you want to do when solving for M2 is multiply by d squared on both sides. This makes it so you're able to cross out the d squared in the denominator. So you're left with f times d squared equals gm1 m2. The next step is to divide by gm1, so you're only left with m2 on the right side. Your final equation ends up being f d squared over gm1 equals m2.
So the next thing is quite simple. All you have to do is plug in the units that I stated earlier. So we know F is N, so your equation is going to be N over G, which was nm squared over kg squared, and that goes in parentheses. And then we know that m1 equals kg. Now this is just simple crossing out, and so all you do is you cross out your nm squared on both sides, so that gets canceled. And then this, because you have a squared and a non-squared, only one of the kg's cancel out, leaving your answer to equal kg, and that is what the problem asks for, so you know that your answer is correct.